There we go. So André, please give us a brief introduction of where you're coming from technically and maybe personally if you want to, and why you bring in this topic, and then the stage is yours.
Okay. First, let me share my screen. Can I share my screen?
Yes, we can.
Wait a minute, guys, please. Can you see my screen now?
Yes.
Yeah.
Very good.
Wait, is it just me or just I see like a straight line
Yes,
going
it's
in the
just
middle of the
like a
screen?
line through your screen.
Yeah.
Maybe you didn't share the right window, something.
And now
Okay.
You can
Yeah.
see it in that
it's
form.
better now?
Yeah, we can see it. It's enough.
Okay.
I'm gonna start selling you guys this service of making presentations. I will show you later how I make one.
So, very good. I'm glad to see all of you here. I was expecting for the other guys because this is a topic that I really, really like to speak about. And I am André. I am a Java Senior Software Engineer at GFT, which is a consultancy from Germany. And nowadays, I am working on Deutsche Bank and also working for another company called by Sir SEC. It's like a I don't know what is the word, but cartório,
Registry office.
registry office. So today, I will I will talk about event-driven architecture. And first, you have any question? No?
Why are you talking about this topic? I mean, you
Yes. I was challenged by Alison to talk about this. And thank you. This. Uh, and this is I think what I suggested a few weeks ago for us to make talks about uh, topics that we know or topics that we want to learn. So fortunately, I know very well this topic, but the idea here is also talk about things that we don't know yet and make this for the studying purpose. Okay.
okay?
So
Wait,
let's
just
get
another question. Sorry to interrupt again. But Alison was the one that challenged you to talk about this topic.
sorry, repeat, please.
So you said that Alison challenged you, right?
Yes.
And Alison, why did you pick this topic?
I didn't understand your question, Gustavo.
Did you challenge André to talk about this topic specifically?
Yep,
And why
last
this
week. Because when I had to talk about something, my subject was CQRS, and I think CQRS is very relation with event-driven architecture and event storm. So I think it's a complement. So usually when you use CQRS, you work with event-driven architecture. So that's why I challenged André to talk about this topic.
Perfect. Okay, André, so no more interruptions. Take it away.
Guys, I want to see the notes while I am presenting you, but I don't know how, because the notes will help me.
You can
That's
share
that.
just a window and it can open on your computer. What kind of notes are you talking about?
Footnotes. I have footnotes here. Can you see?
Oh, I see.
But I don't know how to present and also see the notes. I think I
There's
need
probably a
to-
mode specifically for that.
Yes.
It's probably name printing. I must be
Let's try open a PDF and on my other screen, I will see the notes.
okay.
If it can work.
Yeah, it's a good idea.
Okay. Now it's good.
Yes.
Okay, so the beginning, guys. Event-driven architecture, EDA, is a software architecture paradigm in which a communication and coordination between systems are based on production, detection, and reaction to events, promoting the coupling and scalability in these environments. That description is given by ChatGPT, and thank you for this. But we can go deeper in this topic. Event-driven architecture means if a way to make your system works on a distributed environment, and you will do it with the help of a component called by message broker or event broker, and you can use a lot of tools for this. It's like a pattern, and you have tools that implemented that this kind of pattern, and you have different ways to implement this kind of pattern, as we will see in the next slides. So the most important things to know about this is that EDA promote you very good decoupling and scalability. The scalability in distributed environments. This is the most important thing why we do EDA. Okay. So let's try to. I will try to explain EDA for you, given an application as an example, right? Because I believe this is the most easy way to present and to know about what we are talking about. And we will have a real example of using this architecture. So let's try to imagine a common application that we build nowadays. We have synchronous communication. We probably will build something based on HTTP and REST APIs. So we have our client, and we will make requests to our API, REST APIs. We can make a get, a post, a put, or delete. And our application will make requests to the database as well. And okay, we can have all of your business logic here running here, and we can make it using microservices, which is already a really good pattern to solve that kind of problem. Now I want to present you an application example, which I believe it's very good to demonstrate the principles that we want to learn here today. We have hotel booking application, and let's try to imagine this running into microservices, right? So we have here our customer, and he wants to make a new booking. So we have a microservice called MS booking, and this microservice is very responsible to to coordinate the process of creating a new booking. So it will need to make a request to the MS payments, which is the microservice responsible to handle the payments, running all the logic, make the request to credit cards servers, and etc. etc. We will have to query data from your customer, so you need to know something about him, and we'll have another microservice for to do it. And we will have the MS hotels, which is the responsible to give you the availability of your hotels and the prices and the information about your rooms and etc. etc. And we also have the MS notification, which is the responsible to notify our customer about the payment confirmation, booking alterations and payments and whatever, things like this. You got the point. Okay, so this is a common way to imagine this application, just using the pattern, the microservices pattern. What are the disadvantages of this architecture? We have a really high coupling. Now, I want you to imagine how to add a new component here. We will probably have to change some of the existing components. So, getting back to that slide, I want you to imagine we don't have yet this component implemented yet in mass notification, and now we want to implement that component. We will need to change the MS booking to make the request to the MS notifications microservice. And by doing this, we are creating a high coupling, and this is not good when you are talking about software development. It's not good even in a code level and also in an architecture level. So imagine how much more our software is decoupled. It's more good. Okay. So it's also not real time. We can have price changing, hotel availability changes, and all of these. And this kind of architecture can't do it for us, make the things real time. So imagine we are creating a new booking, and while we are doing this, we have a price change. So the process of booking will be affected. And also availability, which is something that is a real scenario. Imagine that you are trying to book a room in a hotel, and while you are doing this, another person make the booking first. So it's not more available for you, and this architecture can give you issues with this. And it does not scale in the most efficient way. Okay, here we have a microservices architecture, which is really good to scale up things, but it's not the most efficient way, because imagine that we are in the end of the year where people usually travel more, and we are having a lot of bookings, and the payments, the microservice payments is also really affected for this high demand. But now imagine that for some reason our third-party APIs, because it will probably depend on third-party APIs, because you will not you need to call APIs from partners to confirm your payments, like banks or Visa, credit card, etc. And this is being affected. It's running slowly. Your MS booking will be really affected because of due to the bad behavior of this component. So you will have your entire application being affected because of only one component. And it's not fault tolerant. It's not. Yes, you have a kind of fault tolerance here, but it's not. You can make it better, right? Because imagine if you lost some of the requests here, you will not have a way to an easy way to reprocess that request. So that's why we need to think about using another architecture styles. So let's go adapt our application to use event-driven architecture. Here we will introduce another component called event broker. So this event broker is the guy responsible to handle the events and broadcast that events to the consumers. So if we have producers and we have consumers. A producer is a guy that will create an event and will publish that event for the interested consumers. So taking as an example by a new booking. Wait a minute. Let's go create a new booking. So now we will call the MS event broker. This is just an example name because I was not able to think in a name, a better name for this, but you can imagine it wherever you want it here. Now all the components are independent. MS notification will subscribe the topic, and the other components don't need to know about the MS notifications existence. So before, if you want to add this new component, we were required to change the MS booking to make the request to the MS notification to notify the customer about the changes in his requests, his bookings. And okay, now we can add the MS notification without change the other components of our application. And not just this, but we can add any component to our application because now we have the event broker in the front of all of our microservices. So we are creating here a new booking, and MS event broker will create a new event of that booking, and it will broadcast to all the interested microservices. And we also can have other use cases like price changing, and we'll have the event broker broadcasting also that message to other interested applications. Okay, now we are just creating a new booking, making the request to the company app. The company app will create the event, and here we have the broadcasted event, new booking. So we create the new booking on MS Booking. We will create a new payment order for that booking, and we will notify our customer about the creation of that booking. By booking creation, it not means it's already confirmed. We have more steps to complete the booking, and the customer will be notified for every step of that that events. Now our application is running entirely without communication with the customer. So once MS payments process that payment request, we will have the payment confirmation event. This is another. It can be another different event from booking, or we can create the just an status for the same event. Now we have the same event here, but with the status of payment confirmation. It will be sent to the event broker, and the event broker will broadcast that change for the other microservices or consumers. Now our microservice MS booking will have the event of payment confirmation, and here we can do all the business rules related to confirmation. For example, we can confirm the booking of our customer, and we can send we also can send a notification of the payment for the customer. And the most important thing here is you can see all of the applications are running independently. So they are receiving the events, and they are not depending on each other to process that kind of events. So here we have the booking confirmation now, and send it to event broker. Now MS hotels is a different microservice, needs to log the availability of that room, that specific hotel, and we also will have the notification sent to the customer. And what are the advantages? Guys, if you have some question, please feel free to ask. I don't know if I'm speaking really fast, so please advise me if I am. Okay, what are the advantages of this new the proposal of this architecture? Adding new components is easier because we don't have to change anything on the other microservices. Of course, if you want to add a new status of processing, probably will need to change because you are introducing a new business rules that probably will affect the other microservices, but it's not related to infrastructure. It's more related about the business rules of your company. Now it's really close to real time. Things are running asynchronously now, and event oriented. We have the booking creation, confirmation, canceling, and booking also can be changed, like the number of guests of the booking, anything like this. And now we can scale better, much better, our applications. Let's take that as example that I give to you of the MS payments. MS bookings now can be scaled independently of the MS payments. So imagine we are receiving a lot of booking requests and also a lot of booking of payments requests. So now MS payments can run independently of MS bookings, and on the way that we were doing before, just with microservices, to receive more payments requests, we will depend of MS bookings. Now they can scale based on the necessity of each one. And now we are more fault tolerant. If one of the components fails, we can process the event and the response to the client will be less affected. It still can be affected, but now it's less affected. Because imagine this example, just the confirmation of the payment will be delayed. So the rest of the process can be secured. And here I try to give you more an example of the using of the architecture, then call about the technical aspects of this architecture. So which is also really important. For example, we have dead letter quills. So first, let me talk about the difference between topics and quills. So we have two ways of to implement the message brokers patterns. We have topics and quills. What is a quill? Imagine we are creating an event and we are sending our events to the message broker. A quill is a way to organize this. So the first event that you send to your broker will be the first consumer. So this pattern we call first in, first out. So it will be the first to be published, it will be the first to be consumed. And you can have just one consumer for your quill. You can have as many as you can producers, but only one consumer. And you also have topics. Topics is quite different because you can have many consumers and many publishers as you want. And you don't have the same of first in, first out. Things can be consumed in a different order that they were published. And you have different implementations of this, so this is not true for all the cases. Sometimes you can choose between the order of the events, which in some cases it really matters. But it's more related about the specific tool that you will use. For example, Kafka or RabbitMQ or the cloud providers such as Google GCP PubSub or Amazon SQS. And okay. We also have two different ways to implement the EDA architecture. We have the event notification and event carried state transfer. What is the difference between them? When you have event notification, you have just the notification that something occurred. For example, the payment. The MS payment will send the event for the broker, and the other applications will be notified about that event, and the other applications are responsible to query data from anywhere. So imagine that we are receiving information that okay, that payment was confirmed, but you have just the ID. You want to know more things about that payment. So you will need to query another service to know what are the attributes of that entity called by payments. Okay, and the other way is event carried state transfer. This is when you have all the data related to that entity or that event transferred in the payload. So let's get back to our architecture design. we are making a new booking now, and MS Booking will receive the booking data. And if you are doing just the event notification, the MS Booking will just send the event broker the ID of the booking to the MS Payments, and the MS Payments will need to query the data from our database or from the another microservice to enrich the data of the booking. And if you were doing the event carried, the MS Booking will send all the data related to the booking to all the others, to all the other microservices. A really important aspect of working with EDA is the serialization, because imagine we are running off with millions of events per minute or per hour. Imagine we try to do this using JSON. So all the time you will send the data of the event, and you will have duplicated information that you don't need in your payload. So it can make your application run slowly, because you are sending a lot of unnecessary data when you are using JSON. So imagine we have 1 million bookings trafficking in the message broker, and you have the name of the fields of each of the bookings. So you have client name, for example. You have client name, and you will have the client name duplicated, not duplicated, but repeated in every client of that array. So we can have more traffic weight increased here. And ways to solve this is by using another types of serialization. Avro is a very popular one when we are working with EDA, and also Protobuf is a really good one. And of course, we have the tools that will help us to implement the EDA, which is Kafka, RabbitMQ, PubSub, SKS, AMQP, and each of those tools will have their specific ways to implement the topics and the quills, or they will have their specific particularities. Kafka is one that you have topics, but that topics are split into. Let me try to remember the name. They have Kafka will have a really specific way to implement the message brokers. It's just to ensure the specific.
Kafka is stream based, yeah.
Yes, stream based, but it also have I forgot the name of the structure that Kafka uses to store the messages. Let me try to remember.
Zookeepers?
No. I'm talking about the logic structure. You have topics, but topics organizes the messages inside. I don't remember what is that.
Consumer groups?
Yes, consumer groups is
It's split by consumers. Yeah.
Yes, but you have another word. Let me try. I'm searching. Just wait a second. partitions.
Oh,
That's
yeah,
the name,
yeah, partitions.
partition.
Mhm.
So partitions is the way that Kafka uses to ensure that you can have, if you want, of course, ordering of your events, or if you will not lose any event. I forgot to say, but uh, uh, no, I will say it's in the next slides. There are the disadvantages. So tracing the events, it's not well. Tracing the events can be really dangerous here if it's not well implemented. So of course you can implement something related to tracing, but if you don't do it very well, it can be really hard to detect problems and points of vulnerabilities, or even to detect where your request failed, and you definitely will have more complexity. Consistency is just eventual, but you can handle this with using databases, for example. Making tests is really complex also, and of course you have network latency and overhead, because you are using another uh, another component for your application. So every request must must pass for that component, which is the event broker. So that's it, guys. I hope you like it. Thank you so much. And if you have any questions, please feel free to ask.
We
I
cannot
have
hear you.
You are
Gustavo,
mute,
we
Gustavo.
cannot, yeah, you're muted.
André, a question. Wait, congratulations for your talk. Amazing. A question. Are your clothes and the background in this picture AI? Or is this a real picture?
Yes, this is a real picture.
Wow. Because you have another one that your face looks quite similar. And oh, wait, did he change anything except his face? It's cool. So guys, any questions for André?
Guy,
Yeah, I have
André,
one.
congratulations. I have many questions, not only one. I need maybe we can talk a virtual coffee
Yeah, we
because
Yeah.
can hop
yeah,
on a voice channel Discord to
yeah,
keep.
because about I partially disagree with some concepts that you said, but we can discuss in another talk
For
because
sure.
I believe we don't have time.
But you have like one question to ask him?
One question. Okay.
Make one easy.
One easy. Oh my God.
Take it easy, Carlos. Take it easy.
Take it easy.
A question for me is, are you
how
so stupid? Like,
how
okay.
to control transactions between the services? Imagine in one flow of your application, you have three services exchanging messages, but the second service, the third service failed. You need to hold back the previous
Steps.
steps. How to do that? How to control that? What is strategy or technique you use to do that?
Okay.
Because I
So-
believe it's different databases. Yeah.
Yes. That problem can occur even if you are using the same database, which is very common between the companies. They are running microservices, and by the book, microservices should run in different databases, but most of the companies are running in the same databases, different microservices. And this is the same problem that you will have using microservices. So you can use the same patterns to solve, which is the Saga pattern, which is that can control ACID transactions between different microservices. But what I like to use here is the concept of the status. So taking the same application as an example, if you need to roll back somehow, you don't need specifically physically need to make the rollback, because you can make it not. I'm not sure if it's right, but it's not make the rollback, but you have tools to make it logically using the status of the events. For example, in the case of the booking, the booking will just will have the status of the status changed to confirmed only when you have the payment confirmation. So it's an easy way to ensure that you will have a kind of consistency between your microservices.
André,
But in briefly, that's the answer. The problem is the same of using microservices, and you can skip that problems adopting different strategies. And one of that strategies that I really like is using the status of the event.
Okay.
Perfect. Another one?
Alison, I'm sure you have. Bring it on me.
I won't be repetitive here because I think Carlos asked the same thing in different words, but I think how we can deal when we have for example, if you have to roll back your status for a point before your, for example, let me see. You work in a bank and you make some, I don't know, some transactions in your credit card, but for example, some transaction was, I don't know, canceled. How can you hold back your status? How can you deal with this? How can I say that? Your domain historic. Because when you work with CQRS and event driven, usually you have to deal with event sourcing pattern. And in this case, you work with event storm database. And well, if you know Nubank, for example, you know that Nubank work with Datomic. It's a different database, and this database don't update a data, just generate a new data in new status. So that's it. How can you see that to work with event-driven architecture?
So you already gave the answer.
No, I didn't.
Yeah, because by running EDA doesn't mean that you will not use databases. Of course, you still will use databases. You are just using another component, which is the message broker. But your microservices definitely will need to use databases as well. And a pattern for to have the historic about some entity or some event is event sourcing, which is a different pattern that you can implement by using any specific kind of database that you already gave us. And that's it.
Yeah,
For
but
me, you already gave the answer to your own question.
no, because in the case, for example, in the Nubank's case, they use this different database, this specific database. But if your institution, if your company don't use this kind of database, for example, you just have PostgreSQL or MongoDB, how can you deal with this
That kind
historic
of,
of events?
not sure, but probably it's related to the definition of your entities on database.
Let me see if I got the question, Alison. You asking how can we get the history of data if we're not doing event-driven architecture?
History of events.
Okay.
Because well,
I can answer that. So when you're talking about I'm gonna differentiate SQL from the algebra theory. So when we are talking about databases, we're talking about a system that works with algebraic systems, and those they follow a set of math rules related to formal math, which is like they have predicates, you can have axioms in your database, that kind of thing. Those things they do not teach you in the college usually. You can have there's two big authors about the type of thing. One is C.G. Date, and the other is Pascal. Any book for those guys is like, if you read any book from those two guys, you're probably gonna get the SQL databases right. Most people do not get it right. And on the SQL, let's call it SQL for now. In the SQL world, if you want to have a series of events of how things happened and you also need to be very sure the order of those, you can use a temporal database, which is called like this, temporal database. I believe IBM 2 supports it. No, sorry, DB2 from IBM has support for temporal databases. Postgres has a C plugin called temporal, also supports it, and pretty much gives you all these abilities that you guys are looking for, which you'll probably get with event-driven architecture, but you will do it in a different way, which is using SQL. I can also give you a nice talk about this matter. Tech talk, temporal databases. But be aware, this is a very mathematical kind of thing. And I've seen people lose jobs because they preach it companies to use it. I actually know a guy who lost his job because he was like he was in Brazil Paralelo, which is a Brazilian company. Everyone was into like event-driven architecture, and then he came with temporal databases, showing that it could be way less expensive. And he got like into a lot of fights with the guys, and he got fired because of that. So be careful with this type of knowledge because it's a very sometimes it can get in a way with a discussion like types versus dynamic language. People take it personal. But if you're looking for a different approach to achieve the same result, you have this as well. This is a good talk about it. And a good book about it is Temporal Databases from C.G. Tate. This one. So you have those options. If you were not into like event-driven design, event-driven architecture, you can try temporal databases. If you want it out of the box, you have DB2 from IBM. And if you want to build using a database that you already know, you have Postgres. I think SQL Service also supports it at level. That's it.
right.
Carlos, please tell us one of the points that you disagree with me.
Yeah, I will send to you. I don't know. Our time is out. Yeah.
It's a list. So let's actually you guys can hop on Discord to keep the discussion going. Also, you can bring the same topic next week on a debate. That could be also a way to continue this conversation. So we can finish for today. Let's take a picture. Congratulations again, André. Great talk. Perfect. And I just sent on Discord that Allison's talk is on top of our most watched videos on YouTube. Let's see if André is going to top him. It's a fight. Great to see you.
Guys, I just want to tell you something. That's my last meeting with you, at least for this year. Probably I will get back next year only. Probably February or January. I don't know yet. But I will still be on Discord channel to talk through.
Perfect. Okay, guys, enjoy the rest of your day. Thanks a lot, André, again. Thanks a lot for all the meetings you've been with us. And hope to see you very well in January.
Okay.
Okay.
Carlos, we can talk later at 5 p.m.
Okay.